Good morning, ma'am. My name is P. Kumar from EC department. My roll number is 234G180416. Today my topic is nodal analysis using AC circuits using independent current source with a problem. Introduction to nodal analysis in AC circuits with independent current source. Nodal analysis is a powerful technique used to analyze electric circuit by examining the voltage under different nodes. In AC circuits, nodal analysis can be applied to circuits containing independent current sources to determine node voltage. By applying Kirchhoff's current law KCL at each node, we can solve for the voltage and current in the circuit. Overview of independent current source in AC circuits. Independent current sources are components in a circuit that provide a constant current regardless of the circuit voltage or impedance. When analyzing circuit with a independent current source using nodal analysis, we treat the current source as known values in the equations. The current source value is considered a fixed value flowing into the specific node in the circuit. Steps to perform nodal analysis with independent current source. Indefine all the nodes in the circuit and assign node volume voltages announced to each node with respect to the reference node. Applying KCL at each node by summing the current entering and leaving the node, including the current from the independent current source. Write nodal equations based on the KCL and each node and solve the simulations equation to find the node voltages. Example problem statement. Consider the AC circuit shown with an independent current source of 2A entering node A. The circuit also contains resistor and other components with unknown values. We aim to find the node voltages and nodes B, C and D using nodal analysis. Applying nodal analysis on node B. Write the nodal equations on node B by summing the currents entering and leaving the node, including the current from the independent current source. Express the nodal equations in the terms of the node voltages B, C and D and the circuit components impedance. Solve the nodal equations to find the voltages at node B. Applying nodal analysis at node C. Repeat the process for the node C by writing the nodal equations at node C and including the current from the independent current source. Express the nodal equations in terms of the node voltages at B and D, C and D and the circuit components impedance. Solve the nodal equations to find the voltage and node C. Applying nodal analysis at node D. Proceed to node D and write the nodal equations and node D considering the current from the independent current source. Express the nodal equations in terms of node voltage and B, C and D and the circuit components impedance. Solve the nodal equations to find the voltages at node D. Solving for node voltage. Once the nodal equations at nodes B, C and D are solved, we obtain the node voltages at each node in the circuit. These node voltages can be used to determine the current flowing through the circuit components and analyze the circuit behavior. Nodal analysis with the independent current sources provide a systematic approach to solving the complex AC circuit. Circuit analysis results. By applying nodal analysis with independent current sources in the given AC circuit, we have successfully determined the node voltages at node B, C and D. The calculated node voltages allow you to understand the distribution of the voltages in the circuit and the current flowing through each component. These results enable use to the analysis the circuit performance make informed to the decisions. Conclusion. Nodal analysis is a valuable method for analyzing AC circuits with independent current sources, allowing to use to determine node voltage and the current in the circuit. By following the steps of the nodal analysis and applying Kirchhoff's current law (KCL) at the each node, we can efficiently solve complex circuits with multi-components. Understanding nodal analysis with independent current sources inches out ability to design the AC circuits effectively. Thank you, ma'am. Thank you for giving this opportunity.